What's happening, people? Welcome to today's session. I hope that all of you guys are doing good. I am so damn excited today because today we'll be starting off with a new chapter for all the CBSE 9 students out there. Today we'll be starting off with work, power, and energy. My name is Anoop, and this year is Vedantu 9th and 10th English channel. Welcome, one and all. I hope that all of you guys are doing good, taking care of yourself. Very important, people. Don't ignore all the signs. Make sure that you stay safe. With that said, today we will be starting off with what exactly is scientific work and its numericals as well. I hope you guys are as excited as I am. Make sure to subscribe so that all the videos that comes ahead of this particular chapter, you can be notified of that as well. I'll try to make this chapter as simple, as easy, and as in detail as we possibly can. So do not miss out on any of the videos that comes ahead as well, people. So yeah, with that said, let's get into today's session. Now, what exactly do I mean by scientific work? Let me tell you that in detail as we go ahead. But before that, guys, this is the quote for today. If you're offered a seat on a rocket ship, don't ask what seat, just get on. The metaphor is, people, it's not exactly rocket seat. It says that if you get an opportunity, do not ask too many questions on that opportunity. Get on it, see where it takes you. Whatever it is, you're going to be learning. If it's a good experience, awesome. If it's a bad experience, even more awesome, because you'll know that next time you don't have to do it. So whatever the opportunity that is present in front of you, whatever it is, no matter how silly, no matter how small, no matter how complicated, or no matter how simple it looks, get on it, give it a shot, see where it takes you. All right, so do not say no to an opportunity. You have a chance, say yes to it. Alright, guys, so that's it. Let's get into today's session, which is nothing but scientific work and its numericals. In the sessions ahead, we'll be talking about kinetic energy and numericals, potential energy and numericals, law of conservation of energy and power, and commercial unit of energy. So do not miss out on any of these videos, people. Hit that subscribe button. Make sure that you hit that bell icon as well, and also do not forget to hit the like button as well. Alright, so anyways, let's get into today's session. Work. Alright, now let's take an example. Let's say that you're standing there in front of a wall and you kick a stone. Alright? You are that boy or you're that girl and you're kicking that stone. Forget the part where it comes back and hits you, but you kick that stone. And then what you do is that later you try to push a bigger rock because you're more confident now. So you're like, you feel like Superman and you're like, yeah, let's do this. I'm all buffed. So what do? You decide to push a rock. Now, in both the cases, you are applying a force. You know that force is nothing but what? A push or a pull. Now, you are applying a push force in both the cases. That's awesome. But then you see that in the first stone, the stone is actually moving a certain distance. Whereas in the second case, the stone is not moving at all. You are applying your force. You are sweating. You are feeling tired. You are, according to you, you're doing work. But then is the stone getting displaced or is the stone moving? No. So in which case can you say that work is done? First one or the second one? The answer? The first one. You know why? Because in physics, people, work is not you sweating or you burning calories. Work is when the force you apply does some sort of displacement, or if the object tends to move, or if the object covers some distance. That is the only condition when you say work is done. So for work is to be done in terms of physics, not in terms of real life where you say that you're doing work. In terms of physics, when you say work is done, you have two conditions that needs to be followed. One is that you have to apply a force, which in both the cases you are. But the second case, which is the defining factor, is that the force that you apply should displace the object as well, which did not happen in the second case, but however, it did happen in the first case. So that is why you say that work is done in the first case, but not in the second case. Now, this is the scientific work. Now you get the topic. I hope that you got the essence of the topic. That is why it's called a scientific work. Alright, now, let's consider there's a box. You're applying a force of F in a particular direction. It could be towards the left, it could be towards the right, north, south, wherever it is. Alright, you're applying a particular force. Now, when you apply a force, what happens is the displacement happens. The body tends to move. It gets displaced in a particular, to a particular distance, 5 meter, 10 meter, whatever that distance is. Now, here's the catch. When you apply a force towards the left, the displacement also happens towards the left, not towards the right. If you would apply force towards the right, on the particular box, the box would also tend to move towards the right. So what I'm trying to say is this, guys. The direction of force applied is also a very, very important factor. So whatever is the direction of force, the direction of displacement would also be in the same direction, because obviously again, because force, as you guys already know, is basically something that you apply in a particular direction, right? So displacement will also happen in the same exact direction. If in case that does not happen, we will talk about it later. Now you must be wondering, sir, is that the case all the time? Don't worry guys, I'll answer that question as we go ahead. Now pay attention. Now, if you have to define work, if you're asked in your exam, this is how we define work. Work is said to be done by a force when the force applied, or the magnitude of force applied, is multiplied with the distance moved by the body or the displacement of the body. That is the only condition where you say that work is done. So the formula is W is equal to F into S. F is nothing but the force, S is nothing but displacement, and W is nothing but the work done. So what is it? So work is said to be done by a force when the magnitude of force applied is multiplied with the displacement of the object or the distance moved by the object in that particular direction. But here's the thing, guys. Work is not a vector quantity. Work does not matter, or work does not consider direction at all. Work done does not consider direction. Force, yes. Displacement, yes. But work is not a vector quantity. It's in fact a scalar quantity. What do I mean by this? Let's say I have two boxes, right, which is kept on a table, and I am applying, I'm pushing them both apart from each other, and I'm applying a force of 1 Newton each on both the boxes. And I see that the displacement of both the boxes is also 1 meter. So what is it? I'm applying a force of 1 Newton and the displacement of both the boxes is 1 meter. Now, work on both these boxes is going to remain the same. Why? Because direction is not something that you consider when you talk about work done. Work done does not have direction. It only has magnitude. It only has value. Now, the SI unit of work done is joules. Basically, because if you remember it, what is work done? Work done is equal to force into displacement. And if you remember, the SI unit of force is Newton and the SI unit of work done is meter. So it'll be Newton meter, which is equal to joule. So 1 Newton meter is equal to 1 joule. Now, when do you say 1 joule of work is done? You see that 1 joule of work is done when a force of 1 Newton displaces the body by 1 meter. When the force of 1 Newton displaces the body by 1 meter, that is when you say that a work of 1 joule is basically done. Now, to sum it all up, work done is having two units, Newton meter and joules. Joules, however, is the SI unit of work, and 1 Newton meter is equal to 1 joule. Again, what is 1 joule? It is nothing but when a force of 1 Newton displaces the object by 1 meter. And finally, guys, which is one very, very important, work is a scalar quantity, not a vector quantity. Now, you used to be wondering, sir, displacement is also a scalar quantity, a vector quantity, and force is also a vector quantity. So why is this not a vector? The reason is, people, something that you'll study in your 11th and 12th grade, which is called as dot products and cross products of vectors. You'll study that in your later grades. So these are basically two dot products of vectors would become scalar. It's a scalar quantity. You'll learn that as you go to your higher grades. So I'm not going to get into that right now, but nonetheless, I hope you guys understood this. Work done is a scalar quantity, not a vector quantity. All right, let's move ahead now. Now is where you're going to talk about what happens when the displacement and the force that you apply is in different direction. I told you that generally the force that you apply is in the same, or the direction of force that you apply, the displacement will also be in the exact same direction. But sometimes that is not the case, people. Let's talk about that. When do you say that work done is positive and when do you say that work done is negative? Let's look into that now. Very interesting concept. So pay attention for the next 5 to 10 minutes and we're done. Now, positive work. When the force applied and the displacement of the body happens in the same direction, in the exact same direction, that is when you say that the work done is positive. The force applied and the displacement are in the same direction. That's when you say that work done is positive. So when is it negative? Obviously, you guessed it right, people. If the work done is, or if basically the displacement is in the opposite direction towards that, to that of the force, that is when you say that negative work is done. For example, guys, when you're lifting up a box, obviously there's a force that is acting on the box, which is nothing but the gravitational force, which is in the downward direction. That is your gravitational force. but at the same time you see that the box gets displaced in the opposite direction. It moves upwards. Displacement is in the opposite direction, or basically I'll represent that as S. So displacement is the opposite direction, but the force is in the downward direction. This is when you say that work done is negative, when the displacement and force are in the opposite direction. Now, with respect to gravitational force, the gravitational force is acting downwards, but the displacement is in the opposite direction, and hence you can say that the work done is negative. I hope you understand this. Work done is positive when it's in the same direction, force and displacement in the same direction. Negative when the force and displacement are the opposite direction. That is when you say that work done is negative. So negative is done, positive is done. Can work done be zero? Absolutely yes, people. We have seen that in the very first scenario. If there is no displacement, for example, you're pushing a ball, you're pushing a heavy object, when there is no displacement happening, at that time work done is absolutely zero. But also guys, there is one more condition where work done can be zero. For example, people, if the work done, if the force applied and the displacement is at an angle of 90 degrees to each other, basically like this. I'll use a different color, so I hope you can see this. So this is when you say that work done is zero. If the displacement and force are at 90 degrees to each other, that in this case also guys, work done is equal to zero. You know why? Because the actual formula of work done is not just F into S, it's actually F into S cos theta, and cos theta is nothing but the angle formed between displacement and the force. Now in the case of you applying the force and displacement happening in the same direction, the angle between displacement and force is basically zero, right? The force is also in the same direction, displacement is also in the same direction, so the force and the displacement and the force does not have any angle between them, so it's zero. Then cos zero, as you guys already know, is 1, so F into S will become F into S, F into S cos theta will become F into S. But in the case when it's 90 degrees, I don't know if you guys know this, cos 90, which is a trigonometric value, is equal to 0. Cos 90 is 0. So if the displacement and force are at 90 degrees to each other, then the work done is going to be 0. Why? Because if you substitute the value F into S, cos 90 and cos 90 is 0, so it will be F into S cos 0, F into S is 0, so the entire term becomes 0. So that's when you say that work done is 0, guys. Now these are special cases where you talk about an inclined plane and all that. You'll study that in your higher grades again, so don't worry about it. For now, we are not bothered as much about this as we are about the other cases. Again, we'll be studying about this in detail in the sessions ahead. Thank you for joining, people. That is all. Now before I get into the questions, it's not thank you yet, because we have to do some questions as well. Before I get into the question, guys, if you want to have more such amazing sessions and gain 100% knowledge and 100% marks as well, you can click on the link that is given in the description below. Trust me guys, that link is going to change your life. The link is given in the description as well as in the comment section. So once you click on the link, people, this is what you're going to get. You are going to get unlimited live classes with the highest level of quizzes in every single session with the best of the best teachers. You get to experience the whole world of online learning, the highest level of quizzes with leaderboards in every single session. And people, you get to compete with the rest of the world. Imagine that. I wish I had this chance where you can actually compete with the rest of the world, not just from your state, from your country, but in fact the entire world, and check where you're really at. Are you good? Are you bad? Everything can be understood from those quizzes and from the tests that you take. And apart from that, guys, you have interactive replays as well. If in case you miss out a session, don't worry, people, you can still take part in the quiz. You can still have those leaderboards as well. Don't worry about that as well. Apart from that, people, you are getting a choice to download all the premium content. If you if you want to download the handwritten notes, watch the recording, don't worry about anything, guys, because all of that is basically covered in your Vedantu online platform as well. Apart from that, you have the best opportunity to get your doubts cleared inside the class itself. You will have the master teacher and you will also have the class teacher to help you clear your doubts. So both of us together will be clearing all your doubts inside the session itself. And you have regular tests and assignments. I know I'm going and because there is ton more that you're getting from this one simple link that is given in the description, people. Again, you have regular tests and assignments, and based on these tests and assignments, you get a detailed report card. And more importantly, people, you have 5,000 plus micro courses. Imagine that, 5,000 plus micro courses and crash courses, all for free if you enroll into the pro subscription course. Again, the link is given in the description below. If you were to click on that link, you will also be asked for a coupon code. Enter my coupon code AMEPRO to get those amazing discounts as well. So once you enter into the link, this is what you can get if you go for the 1 month program, which basically is 2,699. If you enter the coupon code AMEPRO, you get a discount on it, and what you'll be paying is basically 2,159. And if you go for the 3 month program, because that is all you need, because your exams are only 3 months away, you would be getting a discount of about 1,400 rupees, and what you'll be essentially paying is 5,599. But think about it, people. In that 1 month, you would have roughly attended about 200 sessions, which is the minimum number of sessions that you would attend. If you were to divide it, you'd be literally paying about 11 rupees per session. And if you go for the 3 month program, if you'd be doing about 600 sessions in that 3 months, and what you'll be essentially paying per session is basically 9 rupees per session, guys, for your own future. Just 9 rupees. Think about it, people. And that pretty much is the beauty about online classes. You're getting a lot more for a lot less. Again, in fact, if you think about it, it's less than what you pay for your lays and for that 1 minute of enjoyment that you get. Again, the link is given in the description. Like I told you guys, this is going to change your life completely, and the code is AMEPRO to avail your discounts as well. With that said, let's get into the topic. Yes, let's get into some quiz questions and try to solve some. Again, people, there are some there are some numericals as well. I want you guys to try out the numericals. Pause the video, try out the numericals. Let me know what is the answer in the comment section below. I'll be looking out for those answers as well. Look out for it, people. Make sure that you do it as soon as you can, because the person who puts out the comment as fast as possible, the first top 3 would also have their names in the next session as well. So here's the question. The work done on an object does not depend upon the what? What does work done does not depend on? Displacement, force applied, angle between force and displacement, or the initial velocity of the object? I guess the answer is quite simple. No? If you remember, work done is equal to force into displacement. So which of this do you think is the right answer? Well, I know that you know the answer. Huh? It'll be initial velocity, people, because obviously the velocity of the object does not matter. Work done is equal to force into displacement cos theta. So basically the angle between force and displacement, you do need it. You need force applied. You also need the displacement as well. But what it does not depend on is basically the initial velocity of the object. So that is the answer. We'll go to the second question. 1 joule of work is said to be done when a force of 1 Newton displaces the body by 1 centimeter, a force of 1 Newton displaces the body by 1 meter, a force of 1 dyne displaces the body by 1 meter, or a force of 1 dyne displaces the body by 1 centimeter. Once again, a very simple question. In the comment section, pause the video. Let me know what is the answer. The answer to this question is option number B, people. It is when the force of 1 Newton displaces the body by 1 meter. That is when you say that work done is basically 1 joule. 1 Newton meter is equal to 1 joule. That is the answer. Moving on to the third question, guys. This is where the problems start. The question is, a student carries a bag weighing 5 kg from the ground floor to his class on the first floor, which is 2 meter high. What is the work done by the boy? Is it 1 joule, 10 joule, 100 joule, or is it 1000 joule? I'm pretty sure majority of you guys would have gone with 10 joule. I'm guessing a majority of you guys would have gone with 10 joule. But the answer, guys, is not actually 10 joule. You know why? Let me explain it. Now, work done is equal to force into displacement. Now, force is equal to mass into acceleration into gravity, or mass into acceleration into gravity, or it's nothing but it's a constant value, which is nothing but 9.8, or we can take it as 10. I'm going to take it as 10 meter per second square over here, just to make my life a little easier. So force is equal to mass is given as 5 kg into 10. That gives you 50 Newton. That is what. So here they've given the mass, not the force, people. So firstly, find out the force, find out the weight or the force, which is basically the same thing. So that will be 50 Newton. Now put it in the equation, that is work done is equal to force into displacement. So this is the first part of the for this answer. So 50 into displacement is 2, which makes it 100 joules. So that is the answer, guys. I'm pretty sure that a lot of you guys would have gone with 10 joules. Directly would have put it as 5 into 10. It's a very common mistake, but it's not actually true, people, because they've given you the mass, not the force. So calculate the force first, then put in the equation to get the answer. Alright, fourth question. Here's another one. A pair of bullocks exert a force of 140 Newton on a plow. The field being plowed is 15-meter long. How much work is done by plowing the length of the field? Is it 2,100 joules, 1,400 joules, 210 joules, or 140 joules? A very straightforward question, because we know that work done is equal to force into displacement. Force is given as 140 into displacement 15. So 14 into 15, I believe, is 210. So that's 2,100 joules. That's all, people. That is all for today. This is your homework for today. Let me know what is the answer in the comment section again. Whoever gives me the answer, the first top 3 would have their name in the next session. So if you want to become famous, yeah, however mildly so, let me know the answer as soon as you can in the comment section below. The question is, if the angle between force and displacement is dash, then the work done is said to be 0. What should be the angle between force and displacement so that work done is 0? Let me know the answer in the comment section below. Thank you for joining. Do not forget to subscribe, people. Hit that like button, subscribe to the channel. And if you want to take part in the NTC courses, these are the links for that as well. You get a 90% discount that is going on right now, and this sessions will be going on till 13th of December. So the link is over here. You can take that link and enroll into your NTC preparation as well. Again, this is the YouTube link as well, vdnt.in/bos, to enroll because obviously it's free. All you gotta do is subscribe and learn from the best of the best teachers. The link for your Vedantu Pro subscription course is given in the description, and the coupon code is AME Pro. Once again, thank you. I really appreciate all the love and support that you guys are showering us. Keep supporting us, keep loving us. Thank you for joining, people. Love you all. Take care of yourselves. Stay safe. Bye bye. This is Anoop saying bye bye for now. Yeah, 2 times. I'll see you in the next one. Take care, guys. See you all. Bye bye.